All right, good afternoon, everyone. I'm now live. Okay. If you wouldn't mind turning in your little notebook to 2.3. We're about to discover something pretty amazing. Okay? About to discover something here. Now, I hope that you already understand that if you're arranging three objects in a row, that there's 3 factorial ways of doing it. Now, 3 factorial is 3 times 2 times 1, isn't it? So how many ways is that? 3 times 2 times 1? 6. But are there really 6 ways of arranging 3 pens? Let's do it in real life. I could start with blue, then red, yellow, or yellow, red. That's 2 ways. Or I could start with yellow and have blue, red, and then red, blue. 2 more ways. That's a total of 4. Or I could start with red and have yellow, blue, and yellow, blue. I mean blue, yellow. So 6 ways, exactly what we said. Remember, my right to left is your left to right. Okay, now, this is a very important consideration. But in real life, quite often we don't want all the objects. We only want some of the objects. Like I might want to take just 2 of the 3 pens and arrange those 2. That's a different problem. And that's exactly what we want to look at here. All right, so on our first one here, we're going to take a little field trip to Vimy Ridge Academy. And they're having an election. Yes, an election for next year's student council. All right? And there are 5 wannabes. There are 5 people that think they have a shot at this. All right? And look at the 5 positions that are up for grabs. What are they? Well, president, vice president, treasurer, secretary, and social convener. Now, of course, these positions are all different, right? They're all unique. You know, if you're vice president, you don't have the same privileges as the president. You might not get to drive the limo, right? Okay? Okay, this is a student council. Sorry, I forgot. All right. Now, look at the people. Look at these people. There they are. They're all in the running for these 5 positions. So a ballot is passed out to you, the student, right? And you get to vote. And in your ballot, there'll be 5 spaces. The first space will be who you want for president. The second, vice president, treasurer, secretary, social convener. Now, how good is your imagination? Can you imagine being in this school and getting this ballot? And it's a blank piece of paper with these 5 blanks on here. And you get to vote. You get to put whatever person you want in each of these positions. All right. So now, this is you voting. You're looking at your card, right? Everybody looking at your card in your mind, looking at it. How many choices do you have to vote for president? 5. Okay, so let's write down 5 right here. Everybody writing this in their notes? Okay, stay with me. Stay with me. Fasten your mathematical seatbelt and hang on. All right, here we go. Now, let's say you pick Daniel for president. That name is now off the list. You've used it. Daniel can't be president and vice president at the same time. Daniel is done. D and D. All right? Daniel is done. So now, how many choices do you have for your next, for vice president? 4. And then similarly, 3, and then 2, and then 1. Now, I'm going to multiply these together to find the total number of ballots we could have. The total number of ballots we can have is found by multiplying. Why? Why multiplying? Because you have to do all 5 parts on the ballot. So you have to pick a president. Now watch what word I'm going to use. Listen, listen. You have to pick a president and a vice president and a treasurer and a secretary and a social convener. Because I said and in between all of those, we multiply. In this unit, and means to multiply. Increase your brain with that. Always remember that, and definitely remember that for the next unit test. Okay? Now, I now want you to use your imagination for a different ballot. A different ballot. This time, there's only 2 spaces on the ballot, not 5. So I'm just going to extend the page here. In this new ballot, it's the same 5 people going for it, but you are now only going to pick a president and a vice president. We're not sure what's happened behind the scenes here. Maybe nobody else wanted to be treasurer or secretary or social convener, so there's no use voting for anybody. Somebody else already got those positions. So we only need these 2 positions now. All right. So there's still 5 people to pick from. 5. And now you've used 1, so 4. So this one was 5 factorial, which is 120. This one is only 20. 5 factorial up here, 120. But this one is 5 times 4, only 20. Now mathematically, how do you change 120 to 20 using dividing? What number would you divide 120 by? Yes, you would be dividing it by 6. That's what happened, class. We have to face it. There's a world of difference between the 2 ballots. I'm going to circle something here. The second ballot lost that. The second ballot lost 3, 2, and 1. It had the 5 and the 4 just like the first ballot, but it lost 3, 2, 1. Well, what's 3 times 2 times 1? 6. In other words, class, the 5 factorial that you used to have has been divided by some other factorial to get 20. And if you said 3, you're absolutely right. Your original 5 factorial was reduced by 3 factorial, giving you only 20 choices. 5 factorial over 3 factorial. Well, you know what? This happens quite often in mathematics. So guess what? Mathematicians have made a formula for it. Here's what the formula looks like. You have 5 people to pick from, and you're going to pick 2. That's what the formula looks like. 5p2. You're probably wondering if you can do 5p2 on your calculator. And the good news is, yes. All right? All right, so let's bring up our calculator. There it is. Turn it on. Turn it on. Okay. Okay, you ready? Now, class, I should say, there's no magic to this. There's nothing up my sleeves, no rabbits, no hats, just honest to goodness mathematics. Watch this. 5. Everybody press 5. Let's do this together. 5. Press math. Go over to PRB. What do you see in the number 2 position? Yes. Yes. So we've said 5, we've said P, we've got to say 2 now. 5, P, 2, and you'll never guess what answer the calculator gives me. Yeah, you do. It's above number 6. Number 6. Okay. All right, so what does 5P2 represent? 5P2 represents, watching, you don't want to miss this. If you had 5 pens and you're going to pick 2 of them, 2 out of the 5, and then arrange these 2. There would be exactly 20 ways to do it. 20. 20 different ways. I'm not going to count all 20 of these in front of you right now, but I promise you there's 20. Whenever you take 2 out of 5, there's 20. We just took 2 out of 5 here, didn't we? And wasn't there 20? Okay, now class, I'm going to introduce the NPR formula, which is just this one generalized. It's in your book. The NPR formula is simply n factorial over n minus r factorial. So let's just look at your book here. It's under key ideas. So you don't have to write it down because the formula is right there for your viewing pleasure. Right there. But if I were you, I'd put a star by it. It's one of the most important formulas in this unit. And you do it by factorials. Yeah, that's a comma. I would ignore that right there. That's a comma right there. I would ignore that. Okay, now class. Of course, we have to play fair here. The number of objects, R, has to be less than n or equal to n, right? So it has to be less than or equal to R. How could you take 6 objects out of 5? You can't. It's impossible. So R, the number you're taking, has to be equal to or less than the number you have. That makes sense. And that's what this is saying. R is the number of objects you pick. You pick R objects, and N is how many you have to start with. So it means, and maybe you should write that right in your book there. It means you're going to pick R objects out of N, right? R objects out of N. Now, let's go back to our ballot question. We did 5P2 on the calculator, and we got 20. Let's do it with the formula now and see if we get 20. Okay, let's see if we do. So I'm going to do 5P2. Maybe I'll put it right over here using the formula. If the formula works, we should get the same answer. I put the n where it belongs in the formula, up on the top with a factorial. So my n was 5. So I put a 5 here and there. And then I put the 2 where it belongs in the formula. The 2 is my r. So I went 5 minus 2. But of course, 5 minus 2 is 3 factorial, right? Okay, now class, this will test whether you were really listening yesterday. How do I reduce this? Pick on the little guy or the big guy? Big guy. So start with 5, 4, 3, stop. Why stop at 3? That's so we can cancel. What's left? 5 times 4 is 20. So class, when we wrote out all the choices using the fundamental counting principle, we got 20. When we used our calculator with 5p2, we got 20. And finally, when we used the formula, we got 20. The answer better be 20. We got it 3 different ways. Okay, now class, I'm now going to attempt a different question. 3p2. 3p2. That's different than 5p2. What would 3p2 be? That's if you had 3 objects, all different, and you're going to pick 2 of them. All right? That would be 3p2. So now, what I'm going to do is I'm going to write 3 factorial over 3 minus 2 factorial, which is 3 factorial over 1 factorial. Does anybody know what 1 factorial is? 1. Very good. Does anybody remember what 3 factorial works out to? 6. So this is 6 over 1, or 6. There must be 6 ways to pick 2 objects out of 3. All right? And I think that's easy to illustrate in real life. I'm going to do 3p2 in real life right here with these 3 pens. I could leave out the yellow one, right, and pick these 2 and have red and green, red and blue, I'm sorry, colorblind, or blue and red. No, that's just a lame excuse, right? So there's 2 ways right there, red and blue, blue and red, 2 ways. Or I could leave out the red one and then have yellow and blue and blue and yellow. Or I could leave out the blue one and have red and yellow and red. Yes? So there's 6. That's how I run my classroom. Okay. Okay. All right, so we're going to do 3p2 again. But this time we're going to say we have letters. A, B, and C. So we have 3 letters to choose from. Or to pick from. Let's use the word pick. And we want to pick 2. Pick 2 out of 3. 3p2 is 6. We just worked it out. And here we're showing all 6 in a row. If you had 3 letters to begin with, and you're picking 2, you could have had A and B. You could have had A and C. You could have had B and A. B and A is different than A and B. All right, these are in different positions. B and C, C and A, C and B. And I guarantee you this. If you have 3 objects and you're only picking 2, There's 6 ways, no more, no less. Not 5 ways, not 7, only 6. All right. Okay. We do have one more thing to do here before we get into the serious examples, and that is this. Suppose you had a password that was made up of 4 letters. 4 letters in your password. I don't know what the letters are. They could be A, C, Z, F, something like that. Notice I said Z, I didn't say Z because I'm Canadian. Yeah, I'm Canadian, eh? All right. All right. So now, okay. In this case, there are 26 ways of choosing each of your password letters. Oh, by the way, there are certain things that they expect you to know on the diploma exam. We call it previous knowledge. We expect every Math 30-1-2 student, to know how many letters there are in the alphabet. We also expect you to know what the vowels are.
A, E, I, O, U.
Yes, sometimes Y, but not in math class. Y is never a vowel in math class. There's always only 5 vowels. So we expect you to know that if you can repeat the letters, there are 26 ways for your first password letter, 26 for the second, 26 for the third, 26 for the fourth. But what if you couldn't repeat the letters? What would these be then? 26, 25, 24, 23. So this is different. So if you cannot repeat, the answer is far different than if you can. So if you can repeat the letters, it is 26 to the 4th power. But if you cannot repeat, 26, 25, 24, 23. What I wanted to point out about our new formula is our new formula assumes no repeating. So that formula can only be used when you're not repeating. Yeah, so if you wanted to do this one on your calculator, you could. If you have 26 letters and you're going to pick 4 of them without repeating, that would be 26P4. That would give you this. Exactly what we wrote right there. 25, 20, 26, 25, 24, 23. Remember, you've got a password that has 4 letters. You're choosing 4 letters out of 26 available ones. Okay. All right, the other thing on this next page, the most important thing here is 0 factorial. I know this seems a little weird to you that 0 factorial would be equal to 1. That's weird, right? Keep in mind that if you're arranging 3 objects, it would be 3 factorial. 2 objects, 2 factorial. 1 object, 1 factorial. No objects, 0 factorial. That one's 6, that one's 2, that one's 1, and that one is also 1. In math class, they decided this a couple hundred years ago, that 0 factorial would be defined as 1. And what it really means is if you have no objects to permutate, there's just one way, which is don't arrange them. I know it's a little weird, but we're stuck with it now, all right? So always remember that 0 factorial is equal to 1. That's an extremely important consideration. Okay. Let's take a look at some examples here. All right. Could everyone try 5p2 on their calculator now? If you need help, I will help you with that. It's possible to use a scientific calculator here. You don't have to have a graphing calculator. The scientific ones do have p functions on them. So, all right, so 5p2. All right, so 5, math, PRB, 2, and then 2. That, of course, is the one we did earlier, right? 5p2, which is 20. Now, this one might be a little bit surprising, but let's do it. 7p7. 5,040. Down below, I want you to do 7 factorial. I know they didn't ask you to do that one, but could you do it anyway? So do 7p7, and down below, underneath, put 7 factorial. And I need someone to tell me why is it the same answer? Yes. That's right. So if you have 7p7, that means you're picking all 7 and arranging them. We did that last class. That was 7 factorial. So for last class, you would have put 7 factorial. For this class, you could put 7p7. That's exactly the same thing. All right? All right, class. First example was rather quick. All right, Matthew. Matt has downloaded some songs. Okay, now just to clarify something, he downloaded these songs legally. All right? He didn't use one of those sites. All right? This is from iTunes. He paid 99 cents per song. Okay? It's all up front, all legal. All right? Okay. Now, online music store. He wants to create a playlist using 6 of these songs arranged in any order. Now, we're not told why he only wants 6 songs. I don't know, maybe his iPod thing is almost full. He can only hold 6 more songs. I'm not sure. But he can only hold 6 more, okay? And now he has 10 to pick from. I want you to take a moment now and tell me what you'd put for the question marks. What would you put for those 2 question marks? Think about it. Read the question again if you have to, and write the answer in your notebook. Write the answer in your notebook. Okay, so that's what I wrote. But you know what? I'm getting a little older. Maybe I made a mistake. I'm wondering how many like what I wrote.
I don't.
How many think that what Mr. Ashton wrote is correct? Can I see your hands? Okay, about half the class. How many think it's incorrect? One person. 2 people. And you know what? You guys are in the minority, right? I'm proud of you. You stood up for what you believed, even though you were in the minority. And usually the majority is right. But this time, the majority is right, so I apologize, but sorry. So this is actually correct. Why? Why is it correct? There's 10 songs to pick from, and we're picking 6. So if it is correct, what is it as a number? It's a big number, but how big? Right? So when I worked this out, I got an enormous number. 151,200 possibilities. Okay, so it would be, in the formula, remember you have to do n factorial on top. So that's your n. This is your n right here, right, Jesse? And that's your r. So what goes on top? N. So 10 factorial. And then on the bottom, 10 minus 6. So 10 minus 6 is 4. So it's 10 factorial over 4 factorial. And Jesse, if you divided these two factorials on your calculator now, guess what you'd get? 151,000, isn't it amazing? 200. So you can't go wrong. Either use the calculator or use the new formula. You get the same answer in the end. All right, class. I've got some good news for some of you. Yeah, some really good news. No, that would be bad news. But anyhow, I've got good news for some of you. If you got shut out on that question, like you didn't get it, didn't understand it, guess what? We get do-overs in life. And our next example is very similar to the one we just did. So you get another chance. You get another chance to kick some math butt here. Yeah, has math been like the bully in the playground for you? Yeah, pushing you around, making you feel like a failure? It's time to kick butt. It's time to get back. It's time for revenge. All right, so take this question on. 9 girls, hear me now, 9 girls are available, right? 9 girls are available to fill how many positions? 3. So we'll be picking 3 out of, go for it. Were you saying no in German or the number 9? Okay. 9. I never know. I'm always confused by that one. All right. Okay. Here's what I hope you did. How many had that? Hands up if you had that. Did you have 9p3? Why? 9 girls are available, and you're filling how many? 3. Okay, I have a feeling it's a big number, but not as big as last time. Is that what you got? 504? Okay. All right. We're going to do a bit more of a challenge question here. No, we're not. There it is. Okay. At a used car lot, 7 different car models are to be parked close to the street for easy viewing. You've all seen it. You walk past a car lot, and there they are. They put their brand new cars up there, hoping that you'll come by and buy one. So it's a form of advertising, right? So they put them on the lot for everybody that walks by to see them. All right? Now, at this okay, this is a used car lot, so these are used cars. But the first thing I'm going to underline here, or circle, 7 different cars. So they don't look identical, they're different. I mean, why would the car lot manager put 7 identical cars there? That would make sense. So these are all different, but they have some things in common. In fact, 3 of them are red. They're different cars, but they're red. They didn't tell us the colors of the other ones. Okay? Okay, so I want you to picture this. And if you can't think of doing anything else on a question, your mind has gone blank, put some spaces down there. If you're dealing with 7 objects, put 7 blanks. It's always a good way to start. Now, we're going to arrange all 7 cars here. So this is not our NPR formula thing. We're not just picking some of the 7, we're picking all 7. And you're going to say, Mr. Ashton, that's easy. When you do all 7, it's 7 factorial. They're on to us. Okay, so usually, can you handle it? Thank you, Mr. Boer. All right. Usually this would be 7 factorial. This would be 7 factorial, except for one thing. Except for 2 things, really. There's a red card each end, and the one very much in the middle. Okay, now, class, I needed to ask you a favor. Down below the blanks, can you put an R under the blanks where there will be a red card? Not on top of the blank. That's what we're going to use how many ways up there. There's going to be numbers up here. But down here, underneath, can you put an R wherever there's a red car?
Yeah, I know.
Did you put R's there at the front and the end? Okay, where's the third R go? Right in the middle. Okay. Now, let's forget about the other cars right now. Let's just think about those 3 red cars. Let's say we're going to put them in first. How many ways are there to put my first red car if there's 3 red cars? 3. How many ways to put my second red car? 2. And how many ways to put my last red car? 1. 3 factorial. Bingo. All right. Now, I'm going to use a different color for the other cars. I used red for red. Makes sense, I thought. Okay. The other cars were not told what they are. So there's 4 other cars, let's say, C1, C2, C3, and C4. They have to go in these blanks. Shh. Listen up. On the next unit exam, you may find yourself, when you're in the middle of that test, you may find yourself thinking, when did we learn that? This is now when you're learning that, okay? This is the moment, okay? This is the moment. All right, so I'm going to put a 4 here. Why? There's 4 ways to do that car. It is absolutely vital you get, this is a harder question. About 15% of the diploma exam is harder questions like this. So you got to be ready for it. Then 3, then 2, then 1. Now I could multiply all these out, right? Like that. Or I could do a shortcut and just multiply 2 factorials together and get the same answer. Does anybody know what 2 factorials I would multiply? Yes. That's right. So 4 factorial and 3 factorial will give me the same answer. Could you multiply those out for me? Okay. Now that A part, not too bad. But somehow we have to muster up the courage to do part B. Somehow. In part B, yeah, look at this. This is strange. In part B, the 3 red cars have to be right beside each other. Now, why the car lot manager would want that, I don't know. But for some reason, he wants the 3 red ones right next to each other. So, let's use our imagination here. Red car 1, red car 2, red car 3, all together in their own little area. But we also have yeah, they're all different. We also have those other 4 cars, right? Okay, now this is going to be really cheesy, I know, but I'm just going to say it anyway. All right. Can you sort of imagine a rope tied around the 3 red cars? A big rope? Okay, big elastic band. Okay, glued together? No, I don't want glued together. Okay, and I'll tell you why in a moment. But, yeah, they can move around in there. Okay, so a big rope tied around these 3. So in a way, you could think of yourself, and I'm worried some of you are going to miss this. I'm worried a little bit that some of you are going to miss this. You could think of it as not arranging 7 cars anymore. You could think of it as arranging 5 cars. And you're saying, you got to be kidding, Mr. Ashton. No, I'm not kidding. 5 cars. Why 5? You could think of this as 1 car. Yeah, you could think of this as 1 car. Does that make sense? So then if this is 1 big car, right? How many cars do you have then? 5. 1, 2, 3, 4, 5. How many ways to arrange 5 objects? How many ways to arrange 5 objects? 5 factorial. And that's 120. But, there's one more fly in the ointment. That's an old expression meaning there's a problem. And if you look at this bundle of red cars that are tied together, we could mix them up within their little rope thing. So we could also scramble up the red cars. And here, we could have R1, R2, R3. We could have R1, R3, R2, and so on. So there's 3 factorial ways to arrange the red cars in their little group. Whoa. Okay, I have to ask a very scary question. It's always scary for a teacher to ask this. How many understood where I got that? Let's see your hands. Okay, thank you. Thank you. All right, so does anyone have an answer what you get when you multiply these two out together? Did anybody get 720? 720 is the right answer here. Okay, so if you do it carefully on your calculator, that's what you should get. Okay. All right. Okay, now, class. What? I've got another example. Example 5, it's not on here. Okay, wait. Wait. We have plan B. Insert a blank page. Insert a blank page. Yes. Okay. All right. Thank you. Okay. If I'm not sure how many of you have started working, but if you have started working, like on a job somewhere, then you have to have what's called a social insurance number. So don't tell us all, okay? Now, guess what? They have been giving out social insurance numbers for decades. And they give them out in order. So like mine starts with this. That shows how old I am. I must be 61.7 years old. No, I'm not. But that's how old. And one of you young guys have probably got 9 something now, right? 7? How about you, Mr. Boer? Where are you? Okay, so the sixes are gone. That's my era. Okay, I'm from the 6 era. You guys are from the 7 era. But regardless, every social insurance number has how many numbers in it? Were you saying no in German, or you meant 9 as a number? Number 9. Okay. Okay. So there's 9 of them. Now suppose in real life we do allow repetition on this number. How many numbers would be possible if repetition is allowed? Is it getting warm in here, or is it just me? Okay. I'm starting to sweat. All right. You may not believe this, but this means that Canada could have as many as 1 billion social insurance numbers. We don't have a billion people, I'll tell you that much. So that's way lots of insurance numbers like that won't even need. Okay? All right, so now, what if repetition is not allowed? Okay. We still have 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. But now it would be 10 times 9 times 8. We have almost all of 10 factorial. What's the only number we're missing from the 10 factorial? 1, which you don't need anyway. So this actually will be equal to 10 factorial. Could you get me 10 factorial on your calculator? Okay, now class, the last part of the last example. This question could also be done with P. If repetition is not allowed, you can use NPR. What would be the question marks for social insurance numbers in Canada if repetition is not allowed? It would be 10 numbers to pick from, and how many are you going to pick? 9. And if you do 10P9 right now on your calculator, you will get 3,628,800. What's wrong? Be still my heart. Okay. Shh. Okay, I want to talk about your assignment. And rather than just throw you in there like sheep to the wolves, I am going to, I can't believe I'm saying this, but I'm going to do part of your assignment for you. I can't believe it, but I am. All right, so if you wouldn't mind turning to 2.3, I want you to take a look at page 32. Here's the assignment. All right, your assignment is this. Page 32 and page 33. I'm going to assign number 1 through 7 and number 9 through 11. But I'm going to do 7A right now. Okay? 7A, I'm going to do it on the board. 7 part A. That's it? That's all I got? All right. I'll be very quick. 7A really quick.